Hi, hello. I think we can start. Thank you all for coming. Today's lecturer, Yiannis Chatzikonstantinou, apart from a dear friend, is a PhD candidate in prehistoric archaeology and osteoarchaeology at the Aristotle University of Thessaloniki, and he's handling the human remains from Tholos being Koumassa, Crete. He's a research associate of the Bioarchaeology Lab of the Vrije University in Brussels. He has worked as an assistant lecturer at the Aristotle University of Thessaloniki, and he's currently a member of the research project TEFRA, directed by the associate professor Sevi Triantafylou. And his research activities involve the macroscopic recording of human remains, experiments concerning pyrotechnology and cremation, application of analytical methods on samples from Greek Mesolithic to the Iron Age. His research is funded by the Hellenic Foundation for Research and Innovation. Today, he will map for us the use of fire in the manipulation of the deceased in prehistoric Aegean. So, Yiannis, thank you. We look forward.
Oh, thank you very much for being here. Congratulations to the organizers of the Atlas seminar. And tonight we are going to travel through fire into different topics, and I hope that you will enjoy the presentation. So, in the last 3 decades, there has been an increase in scholars from different fields of study who have taken an interdisciplinary approach to the examination of burnt human remains derived from archaeological contexts. In years prior, burnt bones were considered valueless due to their pure preservation compared to non-burnt skeletons and material culture unearthed from various cemeteries. In many cases, the burnt human remains were discarded without any attempt for contextual exploration, while the terms cremation and cremated bones were used in an unclear way, leading too often to ambitious funerary interpretations. However, isolated preliminary studies of cremated remains worldwide emerged in 1980. Jacqueline McKinley was among the first scholars to introduce the meticulous recording and macroscopic examination of cremated remains from urn burials. She gave emphasis to the retrieval methods and documentation, including sieving, fragmentation analysis, and weighing. Eventually, techniques for the examination of burnt human remains were developed further through experimental and forensic approaches, which pay attention to the macroscopic alterations on the skeleton exposed to heating. Analytical methods focusing on the heat-induced structural and chemical changes on the bone appetite, incorporating histological, microscopic, and analytical methods were developed, while significant advances in reliable radiocarbon dating of calcined bones were also achieved. Despite limitations, considerable contributions to the identification of the biological profiles of burnt individuals have been introduced using osteometric techniques. Along the same line, individual osteoarchaeological reports incorporating the analysis of burnt human remains and specialized books and volumes about the study of cremations have been released in the past years. 2 exemplary publications, which are edited by Smith and Symes and Thompson, respectively, contain papers that illustrate the multiple ways of approaching and examining burnt human remains from a wide geographic sphere by demonstrating the numerous archaeological questions and multiple social aspects that can be investigated. Apart from the new tendencies in osteoarchaeological methods, there have also been vital improvements in excavation and post-excavation procedures, paying particular attention to the detailed documentation of the human remains within their archaeological context. Now, in the Aegean prehistory, the use of fire in the manipulation of the deceased used to be linked exclusively with the funerary practice of cremation. First, in their Greek burial costumes, Kurz and Brodmann underlined that cremation had been by no means unknown to Greece before its first broadly known occurrence in the late Helladic 3C cemetery of Perati on the eastern coast of Attica. It was widely accepted that the adoption of cremation was correlated with exogenous origins, including the Dorian invasion from the north after the collapse of the Mycenaean palaces. Following Kurz and Brodmann, many researchers in the 90s pointed out that cremation was an innovative mode of disposal which was introduced gradually to the Aegean because of acculturation procedures involving incomers from Anatolia or the Italian peninsula. However, the increasing evidence of burnt human remains from the Mesolithic until the early Iron Age shows that the fire was used in multiple ways to manipulate the deceased while playing a significant role in formulating and negotiating social roles, relationships, and identities among community members. Burnt human remains have been recovered from many sites since the early prehistory in Aegean, indicating a presumably indigenous tradition that altered and adjusted to the local needs of each site. Instead of a pathetic introduction, there are many signs of exemplary pyrotechnology knowledge involving the combustion of the human body since the Mesolithic in the Aegean. The accredited osteoarchaeological studies involving the meticulous examination of burnt human remains have shed light on further archaeological issues related to the differential use of fire in the treatment of the deceased. Not many specialists have been involved in the investigation of cremated remains, Xyrotiris for Soufli Magula and Platia Magula Zarko in Thessaly, Musgrave, Lower Gypsales and North Cemetery of Knossos, Toroni, Lefkadi, Liston, Laya, and some of the first pioneers in the study of cremated bones. Serif Triantafylou has been recording significant bone assemblages from the prehistoric Aegeans, the 2000, recognizing that fire was used in multiple ways in the manipulation of the dead body, following, of course, social rules and preferences. She has recently led the TEFRA archaeological project, which is the first multi-proxy broad investigation of burnt human remains in the prehistoric Aegean. Ioanna Moutafi has also contributed considerably to decoding the use of fire in the early Cycladic period through her research in Keros Daskaliou. When I discussed with Tina about the content of my presentation tonight, we concluded that it would be a good chance to present to you the up-to-date methodology we have been using in recent osteoarchaeological examinations of burnt human remains, combined with some results from remarkable case studies. The methodology comprises the contextual analysis of the archaeological and excavation-related information, the meticulous macroscopic recording of each bone assemblage, the selective application of analytical methods, the targeted application of experimental approaches, and finally, the integration of the overall results into the broad discussion involving biological profiles, biotechnology, taphonomy, and funerary practices. After the cleansing, the bone assemblage is separated into general anatomical categories in an effort to stick together the fragments that used to belong to the same bone. After the sticking, each specimen should be recorded separately in the database as a diagnostic or a non-diagnostic fragment. The recording per diagnostic specimen offers a large quantity of statistical data and enables the comparison between the elements to answer multiple osteoarchaeological questions. However, the whole procedure is time-consuming, while good expertise and familiarity with poorly preserved and fragmented body parts are required. Initially, the minimum number of individuals deposited inside a grave or urn should be estimated. The well-known zonation method concerning the recording of commingled human remains can also be applied successfully in studying burnt human remains. The precise zonation method helps carefully recognize the fragmented body parts and also contributes to a prosperous calculation of the minimum number of individuals. A multifactorial estimation of age at the time of death can be made mainly from teeth, epiphyseal fusion, and metrics following the standards for non-burnt bones. Estimating age in detail is more accurate for the non-adults, while in adults, age can be accompanied by determining biological sex, considering all the sexually dimorphic traits of the skeleton and focusing on the skull and pelvis. Moreover, new revised metric protocols concerning biological sex determination on burned human remains are accurate and used widely in extensive bone assemblages. Observations regarding the population's pathological conditions and habitual activity patterns can also be noted, elucidating the people's biological parameters, including relatedness, diet, disease, musculoskeletal activity, and demography. Comprehending the above features enrich our knowledge of the biological and social criteria for using fire to manipulate the diseased in ancient communities. Regarding the examination of taphonomy, all the biological, physical, and human-induced modifications to the bone assemblage can be recorded. Taphonomy is an essential area of research in funerary archaeology, especially in the study of commingled burials, because it focuses on reconstructing the depositional history of the remains through the identification of post-mortem modifications. Unfortunately, recognizing severe macroscopic taphonomic changes, including erosion and weathering, is often impossible for the charred, partial, or full calcined bones. However, it is essential to record the breaking type, fresh or old, combined with the sediment distribution to understand and interpret the fragmentation level of the bone assemblage. If the bones preserve burnt residue on melted material on their exterior surface, the color and location can be recorded to reconstruct the funerary rituals during the burning process. Afterward, a careful macroscopic recording of the thermal alteration is required. Features of interest related to the effects of fire on human remains involve burning level, color change, fractures, and changes to the mechanical strength of bone, such as shrinkage, warping, deformation, and relative cortical preservation. Color change. Color change on burnt bone results from heat-induced alterations in the chemical composition. This leads the bone to assume new colorations, ranging between dark brown, black, gray, light gray, and white. The recording of bone's coloration is crucial because the color is mainly correlated with the intensity of the burning process and the temperature of the pyre in which the body was burned. The macroscopic archaeological study of Kumasa, combined with extensive experimental work on pig carcasses, suggests 51 shades. Mansell color chart is mainly used to identify the color of each bone fragment's exterior, interior, and core surface. The color recognition is combined with the recording of the burning level, following the guidelines of Steiner, who recognized 6 different burning levels. The accurate recording of the discoloration is significant because it allows us to predict the maximum temperature achieved in a burning episode. A bone with a light brown or even beige color, preserving thermal boundaries and lines on its outer surface, indicates burning for a short period of time at low temperatures of 100 to 300 degrees. Bones with black smoking traces indicate short-term burning in low-intensity fires and temperatures not exceeding 300 or 400 degrees. Completely charred bones prove evidence of burning in unstable burning events with temperatures between 500 and 700 for a short time, lasting from 15 to 60 minutes. The dark gray color, often combined with shades of blue, is formed after extensive exposure, more than an hour, to fire with temperatures ranging from 500 to 700 degrees. Lighter hues of gray mixed with white due to severe carbon, organic, and moisture contact reduction indicate constant heating in high temperatures exceeding 800 degrees. Finally, the totally white color indicates intense burning for many hours, at least 6, and at pyres reaching temperatures above 1000 degrees. Alongside discoloration, different fracture patterns on the surface of charred, partial, and fully calcined bones can also be observed. Fractures are a visible result of the structural breakdown of the bone, linked to the intense pressure exerted on the bone surface during burning. A critical question to be addressed is whether specific cracking forms can provide detailed information regarding the decomposition stage of the bone before its burning. 6 distinct fracture patterns, often combined, are usually formed on the exterior and interior surfaces of the bones and can be easily identified macroscopically. The evaluation of surface preservation and the recording of longitudinal, deep longitudinal, patina, curved transverse, and straight transverse fractures can be recorded during the macroscopic analysis of the burned human remains. Due to the various unstable extrinsic and intrinsic parameters affecting a burning episode, the differential results of the experimental work conducted so far determine controversial interpretations. None of the fracture patterns seems to be a distinct indicator of the precondition of a bone, of a body, before its burning, as almost all fracture patterns have been traced in dry, fleshed, or even semi-fleshed bones. Fractures, therefore, should be considered in combination rather than isolation by meticulously recording the other thermal alterations in the bone. A multi-proxy examination of all the visible heat-induced changes can offer reliable conclusions about the whole procedure of a thermal process. It is worth pointing out that a calcined bone can show one or almost all the combined patterns on its surface. Further deterioration caused to the bones after exposure to fire includes advanced modifications in their initial shape and reduced dimensions accompanied by extreme weight loss. These changes are visible macroscopically in the form of warping and shrinkage. Recording, understanding, and decoding these modifications are particularly significant as their presence greatly defines the osteoarchaeological techniques and measurements applied on burned human remains. Warping represents a type of thermal deformation that affects the morphology of the bone by causing an irregular shape that deviates from the bone's standard anatomical form. Warping can be found in all types of bones. It is most evident in long bones as the interiors tend to become highly convex in shape. Warping is absent in smoked and charred bones and is mainly identified in partially and fully calcined bone fragments because of intense burning episodes that last many hours. One more modification a bone undergoes after exposure to fire is the tendency to contract, often combined with distortion. In particular, the bone shrinks and loses its initial shape due to the multifactorial internal thermal changes in its structure. Consistent experimental studies have indicated some critical insights related to bone shrinkage. Bone shrinkage is identified in all burning levels, but is more discernible in partially and fully calcined specimens. Christophe Snoek and our collaborators in the Brussels Bioarchaeology Lab of the Free University of Brussels are pioneers in the application of infrared and isotopic analysis in burned human remains. A multidisciplinary analysis of the chemical and structural changes on archaeological burned bones can link to recognizing inter- and intra-population dynamics combined with variabilities in burning conditions and cremation funerary practices. An integrated infrared FTIR, ATR, carbon and oxygen isotope analysis is recommended for the burned bones enriched with strontium isotope analysis, which offers essential information regarding mobility, landscape use, and funerary practices. Analytical methods should be applied to selected samples after completing the macroscopic study following archaeological and biological criteria. FTIR, carbon and oxygen isotope analysis offers significant insights regarding the heat-induced changes to the crystal and elemental structure of bone during the burning process, providing the opportunity of predicting and reconstructing parameters of the archaeological thermal episodes, such as the type of the pyre, the temperature of the pyre, the duration of the burning event, the kind and the amount of fuel used during combustion, and the oxidation conditions of the cremation process. Moreover, it is feasible to observe the body's position on the pyre and identify the pyre's location in the environment. Chemical and structural osseous changes are different from body parts burned in an open or closed area, on hills or in the plain, during a windy day or without any wind at all. Moreover, the analytical recording of the organic elements from the burnt bones offers essential details regarding the rituals that accompanied the burial costume of cremation, such as the recognition of clothing and footwear in the burial context. Besides, there has been an effort to recognize the bone's condition and the decomposition stage before burning through some experimental approaches. However, still more research must be done to fully explore all the potential archaeological scenarios. However, it is essential that we can approach the level of technological expertise and knowledge of the people who were responsible for the burning events. That's all for the methodology. Let's go to some case studies. So, Frachti, the earliest indication of cremation in Greece has been traced in Frachti cave in the Peloponnese dating to the lower Mesolithic period, according to some preliminary excavation reports based on stratigraphic evidence. Burnt human remains were mixed with inhumations and isolated bone fragments into the habitation deposits. The osteoarchaeological study recognized human bones belonging to at least 2 individuals, including 1 female and 1 male adult. However, the lack of a detailed contextual analysis makes it difficult to recognize if the individuals were burned together in one burning event. Concerning the thermal alterations, the bone assemblage from Frachti cave preserved various and non-homogeneous heat-induced changes, including discoloration, multiple fracture patterns, and dimensional changes, indicating sustained and moderate burning, leading to charred, partial, and fully calcined fragments. The overall assessment of the thermal alterations informs about a mild use of fire in a short duration burning event that did not attain stable high temperatures. In the Neolithic now, the use of fire in the manipulation of the diseased was identified in many Neolithic sites, mainly in Thessaly and Western Macedonia. Soufli Magula in central Thessaly, dating to the early Neolithic, accommodated 12 cremation in pits and remains of 2 pyres, preserving the burnt bones in situ. The burnt bones were mainly fragmented, of course. The osteological study recognized human bones belonging to at least 20 adult individuals, including 1 female and 2 males. Concerning the thermal alterations, the bone assemblage from Soufli Magula preserved mild heat-induced changes, indicating low-scale burning without extensive exposure to fire. On the contrary, cremations dating in the Middle and Late Neolithic, including sites such as the Spiliou, Avgi, and Platia Magula Zarku, are comprised mainly of calcined human remains affected severely by fire, indicating intense burning events lasting many hours and reaching high temperatures. The pyre-related activities, along with the post-cremation depositional activities, led to severe fragmentation of the bones, limiting the secure application of the widely applied methods for sex and age estimation. In the lake settlement of the Spiliou, 4 urns with cremated remains were identified, including the human remains of 4 subadults and 2 adults. Similarly, in Avgi, 10 urns with cremated remains were unearthed with selected body parts from 9 adults and 1 subadult or non-adult. In Platia Magula Zarku, the earliest organized cemetery in Greece accommodating cremations, 44 cases placed in urns and open areas were recovered, belonging to 27 non-adults, and 25 adults. 6 males and 5 females were recognized among the individuals. Moving to the early Bronze Age, the cemetery of Xeropygado in Western Macedonia included 12 cremations placed in urns, small pits, and kist or stone-enclosed graves. In Xeropygado, cremations coexisted with inhumations, which were the dominant funerary practice. The burnt bones were severely fragmented. The osteoarchaeological study identified human bones belonging to at least 7 adult individuals, including 2 females, 1 male, and 3 non-adults. Concerning the thermal alterations, cremations from Xeropygado preserved severe heat-induced changes, indicating extensive exposure to fire until complete calcination of the osseous surface. The cemetery of Koumassa was first excavated by Xanthoudidis in 1904, while a new excavation project has been undertaken since 2012 under the direction of Professor Diamantis Panagiotopoulos from the University of Heidelberg. The cemetery is located on the northern fringes of the Asterousia Mountains on a steep slope overlooking the Messara Plain. It consists of 3 tholoi, A, B, and E, and 1 rectangular tomb. The cemetery is dated from the early Minoan I to middle Minoan II, based on pottery and radiocarbon dates on the human bones from Tholos B. The skeletal remains of Koumassa Tholos B were found in a commingled state of deposition within the Tholos area. Preliminary evidence concerning the form and the character of the funerary practice were drawn upon the on-site archaeological and osteological observations. Tholos Tomb B accommodated multiple burials that took place over 100 of years, and as you can see, the human remains belong to at least 275 individuals of all ages. More than 200 of them are burned, while 65 are non-burned. Female and male individuals are equally represented, while most of the bone fragments are heavily burned. Regarding the burning level of the bones, a similar pattern is observed. At the same time, most of them are fully or partially calcined, preserving a fully oxidized white color with some bluish and grayish hues on their exterior, interior, and core surface. That means that the bones reached a maximum level of calcination due to their lengthy exposure to high temperatures above 800 degrees for many hours. Moreover, all the burnt bones have severe changes to the mechanical strength. Some of them include erosion of the relative cortical preservation, heat-induced fractures, dimensional changes, warping and shrinkage. The high levels of warping and shrinkage, combined with a variety of heat-induced fractures, indicate that the human remains were burned, preserving a large amount of their soft tissues, or they were burned with some flesh on their surface. Despite the bones, there are also artifacts made with clay or metal which are affected severely by the fire, indicating that they probably accompanied the individuals during the burning process. A Tholos tomb at Livaris Chiadi in southeastern Crete was excavated by Papadatos and Sofianou, while the results were published by Trendafil in 2012. The tomb is dated from the early Minoan 1B to early Minoan 2B, while a high frequency of calcined bones with severe thermal alterations and distortions was revealed. The osteological study supports that the burning of the individuals happened before the complete decomposition of the human remains, probably in a semi-fleshed or fleshed condition. The proposed scenario for Livaris Chiadi is that the high levels of fragmentations highlight continuous removal and post-depositional disturbances rather than deliberate chopping and breaking of the bones, as discussed in the past by Branigan. In Camillari, the bone assemblage from Tholos Tomb A was re-excavated by Girella from the pit where the human remains had been reburied by Dorolevi in the 50s. The new findings were published by Girella in 2019, while the bones were studied by Sevita Dafilou. The cemetery is dated from Middle Minoan 1b to late Minoan 3a2. Most human bones are affected by fire and show variations in coloration and thermal alterations. Burning occurred at different temperatures and lengths of exposure, although intensively burned bones exposed to high thermal energy for a long duration clearly predominated. It is supported that the human remains burning occurred in different decomposition stages in dry fleshed or totally fleshed or semi-fleshed conditions. Despite the bones, there are also artifacts such as kumasa made with clay or metal, which are affected severely by the fire, indicating that they burn together with the individuals. Unfortunately, stratigraphical and contextual documentation from the primary disposal of the human remains is missing. Fea Petra is excavated by Vala and located in Eastern Macedonia and is dated to the developed late Bronze Age. All burial enclosures yield traces of fires that accompanied the secondary manipulation of the deceased, taking place directly on the ground or in clay vessels. Additionally, in the same assemblage, a secondary mortuary treatment was identified that involved burning primarily on the skull and partly of the upper skeleton after complete decomposition of the body as an act of fumigation. This was identified in 4 individuals out of the estimated total of 12 recovered in the burial enclosures. The coloring of the bone, which ranges from brown to black, and the lack of alterations to the bone structure suggests that burning was of short duration and at low temperatures and took place after the complete decomposition of the body. And let's move on to the Iron Age. The cemetery of Eltina in Iraklio, Crete, includes various types of tombs dating from the Subminoan to the late Geometric period. Inhumations and cremations in urns and amphorae coexisted for many years. They were associated with prestigious grave goods as a part of complicated funerary activities and rituals. Regarding the use of fire in the manipulation of the deceased, 40 cremations in Pithoi, amphorae, and 1 lekanis were revealed. Among the burnt human bones, many medium and small-sized pottery pots, jewelry, weapons, arrowheads, and daggers, often with traces of fire, were deposited inside the urns or around them in the graves. Each urn contained at least 1 individual, while some cases had 2 individuals in the same urn. Both biological sexes are represented, while human remains belonging to adults and non-adults were identified equally. Concerning the thermal alterations, cremations from Eltina preserved severe heat-induced changes, indicating extensive exposure to the fire until complete calcination of the osseous surface. The necropolis of Prignas in Iraklio includes at least 680 tombs excavated by the Italian school and recently investigated by Antonello Pautasso. The tombs form a continuous sequence consisting of 3 phases from the end of the 13th to the middle of the 6th century BCE. From the first phase of use come a few simple cremations, typically not in urns, placed in oval rock-cut pits covered with stone slabs. These burials were scattered throughout the area and usually isolated. Cremations were associated with stirrup jars and inohoe, a large bronze bowl, and other bronze and iron artifacts, such as a rod, axe, spear, and sword. The second phase consisted of tholoi with inhumations, with the earliest tombs concentrated around the foot of the northern hill. Burials of the third phase were typically earned cremation supported by stones and carefully placed under rubble to form one single uniform tumulus or mass of stones. Over 200 tombs of the third phase have been found. Most of the urns were upright, though some were placed on their sides, and the mouths of the vessels were closed with bowls or stone slabs with the grave gods placed inside or beside the urn. So, the thorough macroscopic, analytical, and bibliographical research involving archaeological, experimental, and ethnographical parallels regarding the effect of fire on bone structure can shed new light on the technological aspects of using fire in the manipulation of the deceased in prehistoric Aegean. In particular, observations can be made concerning features of the burning process and burning conditions, quantity, availability, and type of the fuel used in association with the duration and the thermal intensity of the cremation pyres, information regarding the use of space in the landscape and in areas where the thermal episodes were happened, and conclusively suggestions connected with the amount of energy expenditure and the level of technological expertise related to the burning of the human body in prehistoric Aegean. Moreover, the systematic macroscopic examination, the recording of the heat-induced changes, and the application of analytical methods on the bone assemblages can offer crucial information regarding the variable conditions implemented for the cremation of the human body. Furthermore, the correlations with the published osteological data obtained from other case studies in prehistoric Aegean offers the opportunity to understand extensively the different local uses and cultural traditions of fire in the manipulation of the disease through time and space. If you are interested about cremation and the use of fire in the manipulation of the deceased, you are all invited in our workshop in the end of the month in the Aristotle University of Thessaloniki on behalf of the research program TEFRA. You can visit us on site or you can visit the link through the Zoom. In the end, I would like to thank Sevgi Trendafylou for her continuous inspiration, support, dedication, and friendly supervision during the last decade, and Professor Diamantis Panagiotopoulos for the provision of Koumasa Thallos B bone assemblage for my PhD. I'm also grateful to Professor Christophe Snook and my colleagues in the Brussels Archaeology Lab, and also my friend Elisabeth Stamataki from the Free University of Brussels, who patiently trained me to apply the infrared and isotopic analysis to the burnt bones during my stay in Brussels. Many thanks also to the undergraduate students from the universities of Thessaloniki, Rethymno, Athens, and Ioannina for their significant assistance during the various stages of the multi-proxy analysis of the bone assemblages presented tonight. Last but not least, I would like to thank Dr. Tina Kalatzopoulou for her non-stop support, assistance through my crazy archaeological journey. And of course, thank you all for being here tonight. Thank you very much.
Thank you very much, Yiannis, for this very intriguing talk. I've learned many new things about osteoarchaeological approaches to funerary archaeology. I'm sure there are many, many interesting questions from the audience. If that is not the case, for now,
I'll burn you.
Perhaps I could start with one observation or suspicion that I had without having any expertise in the area. But one would suspect that with higher burning temperatures of funerary pyres, that might correlate to social status. Is that something that you see in your case studies that you are dealing with? Is this a valid observation, or is there no correlation whatsoever? And also, if you take that thought a little bit further, can you correlate, in general, cremation techniques? So I was very intrigued by the various degrees of cutting, of bones having flesh or not having flesh on them before being burned. Does that correlate to, let's say, funerary vessels through time? So obviously we'd be dealing with a very wide chronological frame ranging from deep into prehistory, into the historic ages. So obviously there are obvious chronological changes. But how that might, is that something that you can observe through your specific focus?
Yes, our main goal actually is to reconstruct the idea of cremation, because we are used in a totally different perspective of analyzing the word cremation. We are familiar with the modern cremations that are actually happened in a very special and standard way. So the first step for us was to clarify that fire was used totally different in many ways through prehistory. And as you already seen tonight, there are many cases where we have a totally different use of fire at all. So the first good thing is that we can recognize something like that. The next thing is that, yes, we can actually reconstruct the burning conditions, and we can connect that someone that has severely affected by fire probably had better burning conditions compared to someone who has not so good cremation. However, we are talking about prehistory, so I think that it's a little bit not very accurate to interpret a funerary practice in a way of kinship or something like that. But from our osteoarchaeological perspective, we can say that someone who burned totally until full calcination needs a very good knowledge of pyrotechnology. If this means something, I think that it means a lot. Because in order to burn someone, we need much expertise, we need a very good knowledge of using and controlling the fire, we need to invest goods and actually sacrifice a big amount of raw material in order to burn someone instead of doing something else, instead of building a temple or building a new house. So yes, that is, we can say something related to society, and also we can compare different periods and different materials, because, for example, in the earliest examples that I presented tonight, for example, in the Bronze Age, in the early Bronze Age, we do not actually have normal cremations, individual cremations. We have a communal use of fire in big burning episodes involving many individuals. So it's something different than the ritual that was used through the Iron Age, for example, where we have indications of individual burning episodes, like those that are also used in pottery. How's the terminology? The paintings. The paintings that we have the ritual of the disease and also the pyre construction, the fuel that was below.
So you have an iconographic evidence.
We have an iconographic evidence, and also we have texts. So we have descriptions about how pyre was constructed through the historical times. So it would be really nice in a further step to expand our research questions and analyze as well the cremation during the historic times, the Roman period or the periods afterwards. It's really interesting. But yes, I hope that.
Yeah, Anne has a question. Sorry, Michelle.
In how far, Yiannis, is it possible, sort of going on the same theme, to see a correlation between the level of, let's say, burning resources in the area and the level of burning in the graves? So are you looking, for example, at some graves where the entire body is down to calcination in areas where there is easy access to wood resources or burn woods and so on? Or is it more than that? Or can you also see a correlation there or not over time? And then I have a second question.
A very nice question, because in general, the preparation, control, and manipulation of a pyre is a very complicated issue. Nowadays, we are not familiar with all these issues, but trust me, in order to construct a pyre, in order to find the proper fuel to use, in order not to add again and again fuel, in order to find the proper position of the body, in order to find the best environmental conditions, you need much time and you need much expertise. So it is interesting that in many cases from the prehistoric Aegean, since the Neolithic, we see that they were familiar with doing all these things. So, for example, in Soufli Mahoula, in early Neolithic, the bones indicate burning in very high intensity conditions. So probably they knew how to do it in general and maybe also in the manipulation of the deceased. Now, concerning the selection of the fuel, so far we cannot say easily which type is better in general. In my opinion, I think through the experimental approaches that I have done so far, that a combination of different types is the most efficient because, for example, if you burnt olive, you will have high temperatures, not very high, but you will have a stability in the general procedure. If you burn pine trees, you will reach very high temperatures, but then you need to add again and again more in order to keep it stable. So far, if you are interested about the recipe of a proper burning pyre, you need equal amounts of olive and probably pine trees. And now we see differences between the same areas. We see that in some cases they used whatever they had available for a quick burning episodes. And in other cases, even in the same cemetery, burning episodes with much more emphasis in the whole procedure. But I think that we have much work to do. And also, in the previous question, yes, we see differences, for example, that in the ways that they manipulated the human remains after the pyre. So, for example, in some cases, they selected some of the bones and they put inside specific urns. And in other cases, they put the whole body inside. So in some cases, this is related with biological criteria. In other cases, it is related with something related with social criteria, and also something from Elpina, from the last cemeteries. That is, it's very, very interesting and nice. In many urn burials, there are many artifacts, and there are many associated grave goods. So we have jewelry and we have weapons as well. And the interesting thing is that, contrary to the past indications, females usually have the weapons and males have the jewelry. So even in cremations. So it's interesting.
There's a second question.
Yeah, I have a second question related to the burning system, because I'm really interested in the whole technology aspect. Once you burn bones to the level of calcination, and the bones get interred, at some stage there will be some form of humidity in the soil being in touch with the calcined bones. And how far does the rehydration of the calcined bones affect your analysis?
It depends actually, because usually when someone is not very familiar with burnt bones, expect something like an ash. I mean, they don't expect that cremations have normal bones in a very good preservation. So if I had now here a burnt and a non-burnt bone, the burnt bones during the burning process are more fragile, so they destroy easily, but afterwards they tend to be more, robust, and they don't break easily because they are totally calcified, and they are
not porous anymore.
they are not porous in a way that actually you can see it. Of course, it's something that it has to do with the case study. For example, in Crete, in some cases, taphonomical sediment easily attached on the bones, while in other cases, the bones are very clear and very easily recognizable. But from my expertise, again through the experimental approaches, if you burn a body and you don't involve in general in many stages, I mean, if you just construct a proper pyre construction, put the body in any position, and then you don't do anything at all, you don't add more fuel, you don't throw water, you don't throw wine, you don't do anything at all, you will have, if you burn one individual, you need at least 1,000 kilo of wood, and you need at least 6 hours in normal conditions, I mean without very strong winds, in normal conditions, until the total destruction of the body and the fully calcination of the bones. But the interesting thing is that, okay, maybe you will have fragmentation because of the whole procedure, but you will have a good preservation of the bones. The bones are very well preserved, so you can apply all the methods that I showed you before. So, for example, if you compare some Neolithic cases that I showed you with very tiny fragments and other cases with big fragments, this indicates secondary activities that took place during the burning process and after the burning process. Either they visited and do trampling, or they intensively broke the bones in order to fit them in small urn vessels.
Yeah, and Michelle had a question also.
Yes.
Yes. I'm actually curious, I don't know if that would be technologically possible, but if there's any way to correlate by degree of warping of bones, potential individuals' body mass and access to nutrition versus malnutrition, because of course more adipose tissue would keep moisture in the bones longer. Versus bones that were burned just because the flesh decomposed already. Is there this subtle gradation where we can actually have conclusions of that?
Very nice question. Warping and shrinkage are mainly related with the preservation of soft tissues in general. And unfortunately, because the study is in progress and all this protocol that I presented to you is in progress actually, we have new things again and again. Now they tend to say that no, it's not related a lot with the condition of the bones before burning, and it has to do mainly with the presence of collagen in the bone tissue. But we will see. Concerning the body mass, something that I'm writing now actually, you can have some indications from the carbon and oxygen isotope analysis. You can compare the values of carbon and oxygen through the isotopic analysis, and you can see different burning conditions. So, in a very simple way, when you have higher amounts of carbon and lower amounts of oxygen, you can say that this specific bone was burned in reductive burning conditions. So that means that probably it was burned in a closed environment or with a big body mass or with more than fuel that it was necessary, and other issues. For example, in Kumasa, there are some indications, but it's not the final result, that males had different body mass than the females. But it's a very, raw information, and we have to be more careful when we analyze in general. But we have some traces. We don't have clear-cut answers, but we have some traces in general.
Oh, that's fantastic. Thank you.
Further question in the back.
I want to first thank you for teaching us a bit more on how to burn people.
We have some videos also in a while.
And my question is sort of related to this. I don't really know much about this topic, but what I'm curious about is you showed us the color changes with time and with the temperature, and also whether the bone is fleshed or not. And I'm actually curious, how do you find out these things? Like, do you try?
So, yes. It's a very complicated issue, actually, because there are not many studies involving all these things. So, the first proper methodology was introduced by forensic sciences. So, we have many reports from the medicine or from the forensics, from car accidents, for other things that are related with burning, and they say that, when you reach 800 degrees, the result is gray or white color to the skeleton. After this, there were other pioneers that were exclusively interested in the study of burned human remains in archaeology. So they collected everything from, similar disciplines, and they proposed a way of approaching a material like this. So in the past, not many years ago, we are not so many specialists in the study of cremations and burnt human remains. We try to do more experiments, not only in humans where it is allowed, but also in animal bones, and we can create scenarios, and we check if our idea is, related with a specific factor that we examine through our experiment. For example, a last experiment that we did was about the burning in different burning environments. We burned a pig in an open area, we burned a pig in a furnace, and we burned a pig in a kissed grave construction. So now we compare the final, we compare the bones. We had similar methodology, we have similar protocol, we burn them all for the same period of time, and now we compare the differences between the color, the shape, the chemical composition, the structural changes to create something additionally.
But by this way, you also came to the conclusion that it requires expertise, I suppose.
By what? I didn't listen.
By these experiments, you also came to the conclusion that it requires expertise.
It requires expertise and much patience also. And yes, you have.
Thank you.
You're welcome.
Another question?
Sorry.
Okay.
Yes.
I'm just curious, if I understood correctly, after burning, the bones decrease or completely, the porosity of bones disappears, or is it complete? So how would you know if there's a shrinkage of a bone versus if it's just a child's bone of adult?
Nice question. Wait to find the proper picture. So here, I try to. Δεν θέλει αυτό. Θα το άλλο. Το κατέστρεψα τον μέσα. So here, for example, I have on the left a non-burnt bone, a non-burnt clavicle, and on the right I have a right clavicle. So you see that we have the same bone, well preserved, but in this case it has a severe shrinkage.
So they're in
It's not
scale?
a child, right?
Do you have something to show? No.
Yeah, maybe, but are they in scale?
No.
This is
So-
the actual scale.
No, it's not a scale. It's
No, but are the
the
bones
same
in
scale.
scale?
no.
Okay, no.
Because this is from Kumasa, actually, cemetery. So we have indications of burning and non-burning in the same place. We don't have the initial dimensions, and after we have some experimental cases that we can say that the reduction on shape is almost 20%. But we see also in situ in archaeological cases that in the same cemetery, for example, you see here a proper clavicle, a non-burnt clavicle in normal dimensions, and here a very shrinked clavicle as well. Or here, this is very nice. This is an ulna, and this is not burned. And here you see a totally calcined ulna with severe warping. You see how the bone is changed. Also a femur here as well. So in this picture, you can see actually a very good preservation of the bones, despite the fact that they are burned. But at the same time, you see that they change a lot in their dimensions.
But yet it's not a child, you know that.
No, it's not a child, because if you see, for example, here you have a clavicle. So here you can check the age. So here, for example, you can see in this specific bone that it's totally formed, and it belongs to an adult.
Great.
Thank you.
Any very last, very short question?
Yeah, sure. Thanks so much for this really interesting talk. I'm also very happy to learn more about burning.
This is my contribution to archaeology.
I hope it's not recorded. No, I'm also very interested in the technical aspects. And I was really fascinated by how you say that it requires a lot of expertise. But I was also wondering then, could you sort of tell us a little bit more about what is this expertise? Can you tell us some do's and don'ts? I mean more.
I have an answer.
How large is a funerary pyre like this? If you have 1,000 kilos of wood, how do you stack the wood? How do you place the body so that it can actually?
I tell you.
It's macabre, but.
Look, not recommendation, my point of view is that if you want to study or record a material like this, if you want in general to study cremations or burnt human remains, you must do experimental archaeology as well. Otherwise, it's something that will still have many questions to be answered. So if you are involved through all the stages of the cremation ritual, you appreciate actually that it's not something simple, despite the fact that now I try to persuade you that no, it's not simple. If you don't do it, you will not understand how painful is it to collect the woods, to break them into specific sizes, to build the proper pyre without accidents, and also the limitations in experimental archaeology are very, strict because you sacrifice a ton of wood, so you must do a good experiment. So you are very stressed from the beginning in order to do a proper experiment. Otherwise, you will pollute the environment and also you will burn money without any reason. So literally, instead of wood, put some euros. It's the same. But yes, my advice is to be involved in experimental or modern forensic case studies. In this case, you will be very careful through the recognition of the heat-induced changes. Because, for example, when I started recording burnt human remains 10 years ago, I thought that when we were talking about cremation, we were talking about, the movies with urns, the grandmother inside the urn that we threw it in the sea. It's not like this. I didn't expect something with so many big fragments. So also, I was not familiar with the coloration. I thought that probably someone who had the black color was more burnt than someone that had the white color. I didn't know that. And then I realized that if you burn a wood, an olive tree, you will see that first it becomes black, then it becomes gray, and finally it becomes white. So it's similar with the bones as well. And you need much patience when you do all these procedures, also to the macroscopic categorization and recording. And also the analytical methods that I presented to you today are very complicated. You don't have clear-cut answers at all. You have only numbers, and you try to create an archaeological scenario that probably would be useful for your study.
So do you use like animal bones from a butcher shop or
no,
bones of your animals?
This is the easy experiment. The most crazy thing that I have done with experiments was that I buried the pig 1 year prior to the experiment, and then I excavated the pig. And it was not totally dry, so it was semi-flesh, it was totally disgusting. Yes, but I burn it, and now we have the comparison between the semi-flesh and the totally dry bones. But yes, in Greece and in Europe in general, we are not allowed to use human remains because of ethical issues. In some cases in Portugal, because the universities there are collaborating with modern crematoria, they have a collaboration without any ethic problem, and they record the data when they burn someone for statistical reasons. But yes, normally we use pig carcasses, not bones, because if you use bones, only bones, it's an easy way to burn something because you need a small construction. I try to build big pyres involving the whole body because
And the humidity.
all the factors. And we use pig because pig is the animal which is closest to our nutrition, so we have common things. And I think that we are analyzing nowadays in some experiments is how seasonality affects the burning of the human remains. If you burn someone with exactly the same position, type and amount of wood in different periods through the year at the same place because of the humidity, the wind, and other factors as well.
At least as a vegan, I feel good that this big serpent.
They are all ill. No, we are not kill them because I have told to my friends who are also helped to these procedures that we need animals that die naturally. So also if you have any animal, probably pig ideally, not ill, and if you know someone that has and it's going to die, I'll bring my van, I'll put it inside, and I'll put it in the fridge, in the freezer. It's in our team, no worries.
But you can see that experimental archaeology has different fields. It branches out.
Yes.
Grayish areas a little bit.
For example, in our last experiment, because it's a very nice opportunity to examine multiple archaeological questions through the experiments involving the cremations. We are collaborating with specialists that are, for example, familiar with pottery, archaeobotany. So in the same pyres, we have put different vessel types, we have put different seeds in order to see if in a proper cremation, all these are affected equally to the bones. So it's a nice opportunity to add your archaeological questions. Also, we collected the fuel in order to do micromorphological studies, blocks, like a proper excavation.
Right. Well, thank you very much. Just just looking at the
yes, sure.
But I can see that you'll be having a lot of volunteers and reenacting our cattle procession.
Of course.
And also the games, perhaps. Following the funerary pyre. In any case, thank you very much once more.
Thank you.
Before we send you off, let me one announcement. So we will be seeing each other here the next time on December the 4th. Monday, as usual, the first Monday of the month. Marcos Kotsianis is from the University of Patras, is talking to us about 3D mapping.
GIS mapping, I think.
GIS, but also 3D stuff.
Yeah, I have no idea.
Anyway, it will be very interesting, so you're all more than welcome to join us on December the 4th. Before doing so, thank you very much again.
You are welcome.
You have intrigued a very, interested audience.
Thank you.